So today we're going to be talking about how to solve equations for our Algebra 1 SOL. Now, equations encompasses a lot of things. It's not only solving for X, you might have a regular linear equation, a quadratic equation, and a linear equation. So today we're going to tackle all of those. So let's take a look at our basic equation. Our basic equation looks like number one, 4x minus 10 is equal to 6x minus 12. Now, that's not the first equation that you were introduced to, probably in like sixth grade, you were given one-step equations. But now, as you have matriculated to Algebra 1, you have been given equations with variables on both sides. So we're going to look at this equation really quickly. I treat them like puzzle pieces. You want to get your variables to one side and your constants or numbers to the other when you have an equation in one variable, like this one, that is linear. So if you would like to take a moment to try to solve it on your own and then come back, feel free to do so. I'm going to teach you how to solve it by hand, but also use how to use Desmos in order to get the answer as well. All right, if you like your variables on the left, that means you're going to have to subtract 6x from both sides. Then you'll end up with negative 2x, bring down the minus 10 is equal to, well, 6x minus 6x is 0, is equal to minus 12 or negative 12. Now it's time to move the constants. We'll have plus 10 on both sides. And now I have negative 2x, that becomes a 0, is equal to negative 2. My last step will be to divide both sides by negative 2. And x will be equivalent to a positive 1 because a negative 2 divided by negative 2 is 1. So let's talk about how you can take that same equation that was just solved and use Desmos to solve it. What's great about the Desmos calculator is that you get to utilize it to check your work and also utilize it to get the answers to some of these questions. So I'm going to go to our Desmos calculator. So on one side, we have 4x minus 10. And then on the other side, we had 6x minus 12. All right, we look at this, it created two lines. And they intersect at 1 comma negative 6. You're looking for the x value. So because you're looking for the x value, your answer is 1. Now, if you would like to use Desmos for these and they have another letter like A, B, C, D, or you will have to change that letter to X because the Desmos calculator is not going to graph anything other than X and Y. So I would change it to make sure that it's X so that you'll be able to get the answer if you choose to use Desmos. So number 2, if you would like to, you could try that one using Desmos where you put this side in and then the other side if fractions scare you. But go ahead and pause the video and do that. But I'm going to show you how to work out number 2 by hand. This is like a doozy because there are several steps to solve this one. One of the steps is to distribute, and then there will probably be, combining like terms. So when you are solving equations, you want to make sure that you remove parentheses, which we have. After you remove parentheses, you combine like terms. After combining like terms, then you will decide which side you want your variables on. Then you perform inverse operations. Inverse operations are opposite operations. So like if you have addition already, you would do subtraction. If you have subtraction, you do addition. Multiplication, the inverse is division. So you're going to perform inverse operations to get variables on one side and constants on the other. And then once you do that, you should be solved. So, all right, so we're going to take time to solve this. There's nothing to do on this side, so I'm just going to write it down again. 1/2 x minus 7 is equal to, there's nothing to do with the 5 yet. So I'm going to go ahead and distribute the -3 to this one and the -3 to this one. We want to distribute a -3. I know it says minus, but we're going to treat it like a -3 so that we can do everything in one fell swoop. A -3 times 5/6, you could make it a -3/1. -3/5 would be, -3 times a 5 would be a -15 over 1 times 6 would be 6, a -15 over 6x. Then you have -3 times -2, which would be a +2. Sorry. -3 times -2 would be a +6. All right, we want to combine like terms. And so we have 5 plus 6. Rewrite all of this. 1/2 x minus 7 is equal to, I'm going to put this -15 over 6 first. It doesn't matter, but I just choose to do it first and keep it in standard form. 5 plus 6 would be 11. My next step would be to add 15 over 6 to both sides. So I'm going to add 15 over 6 to both sides. Move it out of the way for a second, just so we can have some more room. All right. When I add 15 over 6, I'll have here and add it here. Need to make them have the same denominator. So I'm going to change this one with a 6. 2 into 6 goes 3 times. 3 times 1 is 3. So 3 over 6 plus 15 over 6 will be 18 over 6x. Bring down my -7. These are zeros. Bring down my 11. My next step would be to add 7 to both sides. If I add 7 to both sides, I'm going to come up here. I'll end up with 18 over 6x is equal to 18. Not sure if you see it already, but 18 divided by 6 is 3x. And then the opposite operation of multiplying by 3 would be to divide by 3. Once I divide both sides by 3, I end up getting 6 as my answer. That was heavily involved. So that's why it's good to have Desmos there to check our work. So I'm going to clear out my drawings and we'll use Desmos to check it. So don't forget, when you're checking with Desmos, you want to make sure that your stuff is in X, your variables have X's there. And then we'll do the first set, which is 1 divided by 2, x minus 7. And on the other side, we have 5 minus 3, parenthesis, 5 divided by 6. Move that arrow over, x minus 2. All right, if we look at that, we can see where they intersect. They intersect at 6, -4. So that means that our x value that we're looking for is 6. So all that work that I did was correct. Again, Desmos can be your friend here. All right, the next thing that we want to talk about are the types of solutions that equations give you. You have three types of solutions in a regular linear equation. The first type of solution is going to be the one solution. And so just like we just saw for X, we ended up with one solution. You may also have something where, let me just write down types of solutions. All right, you might have something where you might actually have a no solution. And then you have one more type where you will have what is called infinite solutions. That means any value for X or any value for the variable will work. So when you solve your equation like Andre did, Andre solved and he ended up with this final answer. 2 is equal to 0. If Andre has ended up with 2 equal to 0, then that means it is a no solution. Why? Because that means that's an untrue statement and they would never ever be able to find the X that works. So one of the things you can do, if you had this for Desmos, I'm going to show you what those lines will look like. I wonder if you can guess what those type of lines would be. But let's see. We have 3 parentheses X plus 2. And then we have 3X plus 4. Look at those lines. What kind of lines are those? Those are parallel. Parallel lines will never intersect. So that means they will never have values that will be in common. So in that case, if you end up with something where you end up with 2 equals 0, that means you have a no solution. Okay. All right, let's move on to the last thing. For equations, it says for what value of K will the equation have infinitely many solutions? How do you know? So what's significant about infinitely many or infinite solutions is when you end up like Andre did, you wouldn't end up with 2 equals 0. You would end up with 2 equals 2. So that means that that's a true statement. So any value for your variable would work. So that means that what you have on one side of the equation must be equivalent to what you have on the other. So let's go ahead and begin this process of solving. So we're going to remove our parentheses by saying negative 8x minus 2. And on this side, it has 1/2 kx minus 2. It says, for what value of k will the equation have infinitely many solutions? Well, we know that we already have this minus 2 on both. So we need this 1/2 kx situation to look like this. So how can we get this to look like this? What value of k would need to be there in order for it to end up being a negative 8? Well, you can reason with yourself a little bit about this. You can figure that out. What value would k have to be in order for 1/2 kx to be the same thing as negative 8x? Well, the opposite of multiplying by a half is the same thing as times them by a 2, like the reciprocal. So we can have kx is equal to negative 16x. Divide both sides by x. And you will see that the value of k has to be a negative 16. You could have also just reasoned with that. If I have a negative 8x and I want it to look like this half of kx, half of what number is negative 8? That's what you would ask yourself. There's no way to use Desmos for that. That does take some logic, and I want you to kind of think about what you would do. If you want to, and it's been a lot of time, you can take this moment to pause and do the practice underneath the video for equation solving. If you're ready to rock and roll, we're going to move on to quadratic equations. Now, you have a standard quadratic equation, which would look like ax squared plus bx plus c. Make sure you know that is a b, plus c is equal to 0. That is a quadratic because we have an x squared in it. A is always the coefficient or the number in front of x squared. B is always the coefficient of x or the number in front of x. And C is always your constant. So with the quadratic formula with the quadratic equation comes the quadratic formula. When you are using or needing to solve any kind of quadratic equation, you can always use the quadratic formula, where you have the opposite of b plus or minus the square root of b squared minus 4ac, all of that over 2a. Obviously, we can use other methods of solving, but using the quadratic formula will also allow you to use Desmos. All right, so let's take a look at number 1. Emil and Andrea solved the given quadratic equation in different ways and got different answers. Determine which student made an error, explain the mistake, and how to correct it. So we look at Emil. The first step he did was divide by 8 and then took the square root of both sides and got one answer, 3. And look at Andrea. She brought everything over to the left and then she factored. And after she factored, she solved and got x is equal to 3 and x is equal to negative 3. Now, if you don't know how to do it any way that they did it, you can always use the quadratic formula. A couple of things to note. When you use the quadratic formula, you must make sure that your equation is set equal to 0, which is the first step that Andrea did. Now, the a value is always in front of the x squared, so a is 8. The b value is in front of the x value, but there is no b, so b is 0. And the c value is your constant, so c would be negative 72. Now, I'm going to go to Desmos, and I'm going to type in that whole quadratic formula. So the quadratic formula, you don't want to put the x equal, you just put what is equal. Negative b, or opposite of b, plus or minus the square root. All right. Of b squared minus 4ac. This whole thing over 2a. Now you can add a slider, but keep in mind the first thing that comes up is b. So b was 0, a is 8, and c is negative 72. Now, you get the 3 just like Emil did, but don't forget the quadratic formula has plus or minus. So 3 is one of the answers. You have to back out the plus and put a minus, and negative 3 is the other answer. Typically, with a quadratic formula, your answers are going to be 2 answers because quadratic means, has that 2 there. The other way you could have solved this, and it doesn't work every time, so that's why, I recommend you actually, trying the formula out. X squared minus 72. We could have graphed it, and then you look at the intercepts. Negative 3 is an intercept, and 3 is an intercept. you're specifically looking at the x-intercepts. So when you're using quadratics, you want to be careful to note exactly the intercepts. Now, the quadratic formula is very helpful, especially when you see that the answers are not like integers. So like it's going to be harder to do it if you see that they were like decimals. So when you see that it's decimals, you want to make sure you use that quadratic formula in Desmos. Don't forget to do the plus one and the minus one to get your answer. So that is my minus. I would have to do plus again, and then I would do minus. You're going to get both of the answers. All right. Hopefully that makes sense to you. But if it doesn't, please email. So in this case, Andrea is correct. There are a lot of questions on the SOL that kind of ask you to correct errors. So you want to make sure that you do the problem yourself and then see what mistakes they made. All right, so let's take a look at number 2. It says, what are the solutions to the equation shown? Show your work. So we see number 2 and number 3 are both quadratics, and number 4. They're all quadratics. So what I would do, I would probably use the quadratic formula, but the first thing that I would do is make sure that I put everything on the left side of the equation. So that means I have to subtract 4. So 2x squared minus 3x minus 4 is equal to 0. Then you want to identify your A. A is 2, B is equal to -3, and C is equal to -4. Now, Desmos is okay with the quadratic formula, but the problem with it is if you get a decimal, my B is -3. So if you end up with a decimal, it'll probably be better to perform it by hand. So I'm just putting it in here just to see. So you see how we get that -0.8078, that long decimal. That means that this one did not work out to be integers. So because of that, I would recommend you to actually do the quadratic formula by hand. So the opposite of B, the opposite of -3 will be a 3. 3 plus or minus the square root of -3 squared minus 4 times the 2 times the -4. All of that over 2 times 2. So we want to now use our mental space. You could plug this part into Desmos if you needed to, or you could do it by hand. So I will have 3 plus or minus the square root of 9 plus 32 over 4. So 3 plus or minus the square root of 41 over 4. So this is my answer. And then you could verify that. So if you do have it in Desmos, again, I always recommend using Desmos to check. You could do 3 plus the square root of 41 divided by 4 and see if you end up with that same thing. I didn't, but that's because I have the plus first. So what I can do to make sure that it is the same thing, I could change this out to a plus, and you see how it is the same thing. And so my next one to try would be the minus, because remember, you're going to have 2 solutions. So I just did a copy and paste. Here is my minus answer. And I'll go back up here and change it to my minus answer. We have just now verified that what we've tried is correct. So Hopefully that's enough info for you to feel confident to try these ones on your own. So you have 3x squared minus 8x plus 5. And you could just identify that the A is 3, the B is -8, and that C is 5. Last but not least, you could do the same thing with number 4. So if you want to take a break and do the quadratic practice, feel free to stop the video and do so. However, if you're ready to go, we'll do the last set, which is literal equations. Now, literal equations are the equations that you have to use with, literal equations are the ones where you have to solve an equation for a variable. And so when you're doing that, it looks weird, but you still perform inverse operations in order to actually solve. So for example, in here, we are trying to solve for x. And so trying to solve for x, you see that x is already attached to the a, but that means you have to get x on a side by itself. So we really use literal equations when we're trying to get formulas, but it's the same steps. It's just that we can't really combine like terms. Like you can't, a plus b is going to stay a plus b. So let's take a look. If I need this term to be on the side by itself, the first thing that I want to do is to subtract by. So here we get ax is equal to c minus by. So ax is connected through multiplication because they're right next to each other. And so my step would be to divide both sides by a, and x will be equal to c minus by over a. Now they may choose to do it the opposite way and say that x is equal to negative by plus c over a. So you have to keep in mind when you're trying to solve this that they may, switch it around because addition is commutative. Let's look at number 2. Number 2, your task is to solve for b. So b is not on the side by itself, it's connected to y. This is a positive y, so your first step would be to subtract y. Then you end up with negative b is equal to mx minus y. Well, we're not interested in negative b. We're interested in what positive b is. So how do you do that? You can either do 3 things. Take the opposite of both sides of the equations, or you could divide things by -1, or you can multiply everything by -1. So usually what I tell people is to put a -1 there and divide everything by -1. So you end up with b is equal to mx plus y. Keep in mind, they might say b is equal to y plus mx. This is beneficial when you have formulas that you're trying to solve for things. So we're going to look at number 3. Number 3 is asking us to get v by itself. Currently, v is in the denominator. So what we want to do is want to multiply both sides by v because we need it to be in a numerator. So v times d is equal to m. We're trying to get v by itself. What's the opposite of multiplying? It is division. So we're going to divide both sides by d. You end up with V is equal to M divided by D. Last but not least, we have one of these that I consider to be one of the harder ones. They want us to take this formula and solve for C. If you want to pause the video and give it a try, please feel free to do so. Looking at this, it's hard to get C alone when you have C already on one side and C is connected to an R. But this is where your lessons in factoring come to play. So I'm going to factor out a C. So factoring out a C or dividing out a C is not that bad. C divided by C is a 1. CR divided by C is R. So what I just did was divide this by C. C divided by C. Anything divided by itself is 1. This divided by C, this would cancel and be a 1R. And I don't have to put the 1. So now we have P is equal to C times that sum of 1 plus R. And so what we would do is divide both sides by that sum of 1 plus R. And your final answer will be P divided by 1 plus R is equal to C. To me, that's one of the harder ones to do just because it just is not so clear as soon as you see it. Well, this draws us to a close of the equations of Algebra 1. I hope that you would try the practice. If you do have some questions, please feel free to email me at achristineross@gmail.com.